Step-by-step procedures involved in creating a simple stability analysis. Here is a schematic diagram of a simple slope stability problem. The objective is to compute the minimum factor of safety and locate the critical slip surface. Once GeoStudio has been opened, a new Slope W analysis can be created from the Start page by selecting Analysis, creating a new project, or using the File drop-down menu. The first time you start working with Slope, it's helpful to learn what different toolbars exist. In Slope, many of the drop-down commands are also available as individual icons on the many different toolbars. You can familiarize yourself with the toolbars by toggling them on and off, ensuring that they are all visible before you start the analysis. When developing a model, the first step is usually to set the working area, which defines the size of the space available for defining the problem. The working area may be smaller, equal to, or greater than the printer page. The next step is to set the scale. The scale should be set such that the minimum and maximum extents in slope match those required for the analysis. You can define either the x and y extents or adjust the actual scale of the problem. A background grid of points will help you draw the problem. These points can be snapped to when creating the problem geometry. The problem definition data must be saved to a file. The data can be saved at any time during a session. All Slope W files have a GSZ file name extension. It's often helpful to sketch an axis, which will help you define your geometry. The axis is drawn by moving the cursor from the bottom left corner of the axis and stretching the axis outward until the necessary size has been achieved. Once the axis has appeared, the number of increments can be adjusted using the Set Axis drop-down menu. Before defining the geometry and slope, it's convenient to first prepare a sketch of the problem dimensions. To sketch the slope stability problem, select Sketch Lines from the Draw menu and use the cursor like a pencil, clicking the left mouse button to create a series of lines to outline the problem. If you sketch a line in the wrong position, you can go under the Modify pull-down menu and select Objects. The incorrect sketch line can then be selected and deleted or adjusted as required. Once the problem has been sketched, some information about the analysis that is to be conducted should be defined. Choose Analysis Settings from under the Key In menu. Any appropriate text can be typed under the Project ID tab. Click on the Method tab and select the Morgenstern Price method and ensure that a half-sign function is being applied. Under the Pour Water Pressure tab, ensure the PZ metric line option is selected. And under the Slip Surface tab, we'll use the Entry and Exit Slip Surface option for this analysis. Now it's time to define the material properties for the two layers of soil. Choose Material Properties from the Key In menu. Type 1 in the Soil Edit box and choose a strength model. Then use the Tab key or move the cursor through the edit boxes to define the material properties for soil number 1. Clicking on the Copy button will copy the values contained in the edit boxes up to the list box. Then repeat the same procedure for material number 2. Remember to select Copy to confirm the input information for material 2 and to write that information to the list box. To draw the soil regions and develop the geometry within slope, choose Regions from the Draw menu. The cursor will change to a crosshair. Move the cursor over the sketched lines and click the left mouse button to create points. Since the default material is correct, select Close and continue to define the next region. Once the second region has appeared, select the lower soil layer, which is material number 2 from the drop-down menu. Click the right mouse button to exit the Draw Regions mode. The pore water pressure conditions for both soils will be defined by a single piezometric line. Use the All button to apply the piezometric line to both materials. You draw the piezometric line in the same manner you drew the sketch lines or the regions by moving the cursor and clicking the left mouse button at the desired locations. Earlier we selected the entry and exit method to control the location of the trial slip surface. The entry location is defined first by clicking on a point on the crest of the embankment, holding the left mouse button down as you drag the mouse to define the entry range. The exit range is defined in a similar manner. We don't need to view the point numbers or region numbers anymore, so use View Preferences to turn off the point and region numbering. Now that the problem definition has been completed, you can double-check the input. You can double-check the soil properties by selecting the Material Properties command from the View pull-down menu. Click within a region to view the properties for that particular region, or select the All Materials button to view the material property information for both soils. You can use the Dynamic Sketch Text feature to place the soil properties on the drawing as a label. Click on the Insert Field button and choose from a selection of properties that you would want to include in a sketch text label. You can choose to have the properties reported for each soil individually or for all the materials defined. In this way you can create a table of input parameters. If changes are made in the future to soil properties, the dynamic sketch text will automatically update to reflect the new values. Now it's time to verify the problem. Click on the Verify button and Slope W will run a number of checks to see if there are any errors in the problem definition. The solver for slope can be launched by clicking on the Solve icon. Click the Start button to activate the solver. For this analysis, 125 different slip surfaces will be analyzed. You can view the results directly by clicking on the contour icon in the Analysis toolbar. The critical slip surface appears along with the critical factor of safety. Use the Draw Slip Surfaces command to bring up a dialog box that summarizes the factors of safety for all the different slip surfaces analyzed. Clicking on any result will cause both the slip surface and the corresponding factor of safety to appear in the contour window. You can also view the slice force information for the most critical slip surface. Move the cursor inside any particular slice and click the left mouse button to select the slice. The slice force information can be copied and pasted directly into a report or spreadsheet. Although we told the program to use the Morgenstern price method of analysis, results were also obtained for 3 other methods, including the ordinary method, Bishop, and Jambu. You can look at the results obtained using these methods, using a pull-down menu or through the Method toolbar. It's often helpful to look at how parameters vary across the slip surface. To create a graph, choose Graph from the Draw menu. There are many different graphs that can be developed, including a plot of pore water pressure across the slip surface. Both the graph and raw data can be copied from Slope W and pasted into a report or spreadsheet for further analysis. By default, the location of the critical slip surface is shown in Contour. However, you can also view the location of other slip surfaces that were analyzed. Choose Preferences from the View menu. Select the number of slip surfaces that you would like to view simultaneously. The slip surfaces for the 50 lowest factors of safety are now drawn on the profile. At any time, if you want to go back to Define, click on the pencil icon in the Analysis toolbar. You can also return to the Start page by clicking on the Start page icon, and then returning to the current analysis by clicking on the Slope W icon. We have reached the end of this introductory lesson. Not all of the powerful features of Slope W have been used or discussed during this lesson. Specific details about each command are given in the online help and in the supporting documentation for Slope W.